Okay, we have a questions for the factors. Let's say we have a cube. So in this diagram, OABCDFG is a cube in which each side has length 6. So we know that OA, AB, AE, and such are 6 units. And unit vector I, J and K are parallel to OA, OC, and OD respectively. The point P is such that AP, factor AP equals to 1/3 of factor AB. And the point Q is the midpoint of DF. Express each of the factors OQ and PQ in terms of I, J, and K. And find the angle of OQP. For double I will explain using two ways. We can use cosine rule as well as the finding the angle using the factors formula. I will give you a couple of minutes to think about it first, or you want to try it out by yourself before I show you the explanation. Okay, so we've got factor OQ equals to factor OD plus factor DQ. And we know OD is K and DQ is half of DF. Could you see that? DF is twice DQ. And we know that DF would be J plus I, or I plus J. So K plus half times J plus I, it becomes K plus half J plus half I. We can also rearrange it later on alphabetically. It becomes I, J, and K. Next, we want to find PQ in terms of I, J, and K. Okay, actually, as you know, the rule of factor, as long as it starts from P and ends with Q, we can use any path within that cube. So, let's say I have PQ start with PA, it's also okay. If you want to have PB or PE or PF, any, it's also possible. But let's use PA, let's say, and then after that I go to AE, and after that, after E, at the end I need to reach Q, and Q, it's gonna be in the middle, right? Okay, so EF and FQ. Is that okay? Yes, it is. But if you have another options, if you have another way, another route, it's also possible, as long as it start with P and end with Q. Okay, now let's express all the factors in terms of I, J, and K. And PA, we know it's gonna be negative 1/3 of J, as it has been stated there. AP is 1/3 of AB, plus K. AE is K plus J, which is EF, plus FQ. FQ is half of FD, and FD, it's quite obvious, it's gonna be I plus J, negative I plus J. Therefore, FQ would be negative half J plus I. And we can simplify this expression by grouping and joining the same factors, same letters, I with I, J with J, and K with K. So it becomes negative half I plus 1 over 6J plus K. So this is the simplest form of PQ. So this is the expression of PQ in terms of I, J, and K. So we already answered the question of I. Next, we want to find the angle of OQP. So one of the ways, as I told you before, I will explain by two ways. The first way, we can make a triangle like this. So the theta, the angle of OQP, it is on the angle of Q, just like this in the picture. So we want to find this one. Okay, let's name it. This one is M, N, and P. So if you want to use the first way, which is using the cosine rule, we can use this triangle of M and P with M and P and with the angle of Q. And the theta, the angle, the one that is need to find. Okay, using cosine rule, we know cos theta equals to a square plus b square minus c square over 2 times a times b. So if we apply this rule to this triangle, we can get this equation. We can get this in terms of m and p and theta. We can get this. Cos theta equals to a squared, it's replaced with m, let's say. So it's gonna be m squared plus n squared minus p squared over 2 times m times n. And we can find the value of m, which is the magnitude of m or the factor of OQ, by using the formula of magnitude of factor. So m actually is the length of factor OQ, and we know that factor OQ we already found it before is k plus half j plus half I. So the magnitude would be half from the I, half square, plus half square from the j, and 1 square from the k. By using the same way, you can find the magnitude of n and the magnitude of p using the same way, using the formula of finding magnitude of a factor. So what you need to do is just finding it by root of all the component in that factor. Okay, using the same way, you can find the value of m, you can find the value of n, and you can find the value of p. And what you need to do is to put all the values in the formula. And after that, you find the cos inverse of that result to get the value of theta. Okay, after some computation, you will get the theta equals to 52.9 degrees. Okay, as I told you before, there are two ways. So the second way, we can use the formula of dot product of a factor. As we know, if I have a dot b, it's gonna be the magnitude of a times magnitude of b times cos theta. We can use this formula to find the theta. So cos theta equals to a times b over the magnitude of a times the magnitude of b. And we know the a and b here, it's gonna be m and n. So a times b or m times n, according to the dot product, it's gonna be, firstly we need to find the factor of m or the factor of OQ, and we already got it in the I part. So m is the direction is QO times QP. So it's gonna be this one, the negative of that OQ. So a negative k minus negative j minus negative I times with QP, which is the negative of PQ, which is half I minus 1/6 j minus k. And we know that we need to times only with the same factor unit. So I with I, j with j, and k with k. And we got the result is negative 1/4 from the I, negative half times half, plus 1/12 from the j part, negative half times negative 1/6, and k is negative 1 times negative 1, which is positive 1. Okay, then we will get the m times n. After we get this over with the magnitude of m times magnitude of b, the same, the one that I already explained before, then you can just put it into the formula. So cos theta equals all the values that you have obtained before, then theta would be cos inverse of that, and you will get the same result as the first way. So you have two options to solve to find the value of theta.